Okay, so we're getting into 5.9 congruence in two-dimensional figures. This is part one, and the objective of this one is being able to solve mathematical problems involving congruence. Okay, so I pulled this example from the homework lessons, and I pretty much pulled everything out of all the homework questions, and I put it all into one big question. They give you a polygon here, right? Two polygons actually kind of wrapped into one. And then they give you all of these givens. And then they have a solve. They give you these givens, and then they give you this given here. And then they're like solve for a bunch of stuff. Okay. So instead of just, going through that word by word and line by line, I'm just going to show you how I approach these things. And I think it's pretty intuitive to approach it this way and just kind of take all the givens and superimpose them on top of the figure and then just kind of solve the figure and figure out everything about the figure and then go back and look at the questions that are asked and answer it what best you can based upon what you know about the figure. So first thing about this figure is they tell you that the polygons are congruent, right? That's W, B, H, Y, M is congruent to T, K, T, C, H, R, K, Y, or R, K, yeah. So this one, this is like this one is like a reflection on this one across like some line, like let's see if I have like a line, look like a line like I don't know, like something like this. Maybe like this will reflect it across that or something, right? So this point is congruent to that point. This elbow is congruent to that elbow there, right? So you can kind of like identify the things. So what I encourage people to do is if it's not completely obvious which one is congruent to which to you, figure that out right away, maybe with some patty paper, and identify which parts are congruent to which. And so I'll do that now. Before I did this, I went ahead and I just kind of superimposed all of the givens on top of this image. This wasn't given to me, like all these different see how it says like angle, the measure of angle HRC, or sorry, RHC is 2x minus 6. So I put that on there. So I found R H C, and I put 2h minus 6 in there. So I went around and I did all that just to make it easier for me. All right, so before I start marking congruencies on here, I'm going to make it easy on myself. And I'm going to go through here and I'm going to mark up the congruencies. Or sorry, I'm going to mark up the corresponding points, corresponding vertices. And I'll start with like this obvious point here, W. So, W, if you go over here, these are congruent polygons. So you can say W is matched with T. So W is matched with T. And I'll just be like, okay, this over here, this is marked with, this is like W. Okay. So that's W, right? Okay. And then B is marked with C. B is marched with C, so I'll just be like, hey, that's B's mark, that's B's match. All right, cool. That helps. All right, and then H is with H. Well, that makes sense. I don't need to redo that because that's the same point. Then I could say Y is with R. So Y is with R. So this is like R. Okay. And then M is with K. So M is with K. So M is with K. That's so ugly. M is with K. All right, so that helps out. And I could do it to both sides if I really wanted to, but I'm just gonna kind of like use one as a reference for the other. And you could just use this if you wanted to, but I find it helpful for me to put it on the drawing. All right, so now we're like, okay, well, if I want to solve these things, I gotta match one thing to the other. And in order to do that, let me find two angles or two lines that are congruent to each other. And that, I mean, sometimes it's helpful and they'll give me like a right angle and like, hey, this is a 90-degree angle. And this thing is equal to that 90-degree angle. And I'm like, oh, that's easy. Let me just go ahead and set that equal to 90 degrees. Like say, for instance, this angle here was 90 degrees. Well, then that'd be easy. I just set 5K plus 2 equals 90 degrees. And there you go. I already have a variable, but that's not the case here. Or maybe it would be really obvious here if I set, you know, that this angle, a BHY was equal to something else that had a K in it, then it'd be like, all right, cool. And I could just say those two are equal to each other. But it's not as easy here. So let's try to find something that are equal to each other. Well, it's kind of easy, right? So if I have M here, angle BMH, I have the vertex M. It has a K in it, the variable K, and then I also have a variable expression over here that has the variable K, and they share the same vertices, right? So WMK, or sorry, WMY is the same angle as a TKM, and it has K. So I can say, there's my first, that's a good starting point. I can at least solve for K here. So I'm gonna go ahead and say that the measure of angle, well, I guess I could start even further and say that angle WMY is congruent to TKR, to angle TKR. So then I can say the measure of angle WMY is equal to the measure of angle TKR. And if you're wondering why I can say that, well, that's just the definition of congruence. Okay, so now because of these two are equal, then I can just say, well, this equation that represents that angle, I can just drop into here, 8K minus 19 equals, and then this angle here with the vertices M equals 5K plus 32 plus 32. That's cool. All right, so I don't know how you learn to do algebra, but I like to keep my variables positive. I have no like terms to, combine on each side. So in order to keep my variables, this is a K, sorry, K. My variable's positive. I'm gonna have to move this 5 to the other side, or subtract 5 from both sides, whatever way you want to look at it. So I'm gonna subtract 5 from both sides. That leaves me 3K, right? And then in order to get 19 over here, I'm gonna have to add 19 to both sides. So 32 plus 19, gonna be 51. 51. So 3K equals 51. So K. So now I'm gonna divide both sides by 3, and then 51 divided by 3 is 17. K equals 17. So I've unlocked K. So everywhere that I have K, I'm going to change it into an actual number. So I can get rid of all these cockamamie variables. So start with this one. So this is going to be 8 times 17. 8 times 17, because that's what k is, right? 8 times 17 minus is 136 minus 19 is 117. So this is now 117. 117. Oh, I just thought that I can bring this up. Move it over here. Maybe I can make it smaller. Yeah, now you guys can see that. I'll move that over here so you guys can see if that needs it, if we need that. But I'll do that later. Okay. All right, so I guess I'll do it now. I'm still doing math. Okay, so then I'll do this k. So 2, I'll do 2 times, oops. I'll do 2 times 17. Right, and then subtract 6 from that. That's 28. That's 28. 28. 28 degrees. I'm gonna bring back my calculator now and clear that. All right, I can do this one. So 5 times 17. That's gonna be 85 plus 2 equals 87. So this is now 87. 87. Now I have a unique opportunity to check my math here because this should equal 117 because it's congruent to this one. So I'll be really embarrassing now if I check it and it doesn't equal 17 or 117. So let's go ahead and clear this, and it'll be 5 times 17 equals plus 32. And there it is, 117. So this is 117. 117. That's cool. Then I have this other one that has a k in it, and it's 3k plus 2. Oh my God. Here we go, 3k. 3k. Whoops, I put 3 times 17 plus 2 is 53. So this is no longer this. This is now 53. I'll put it up here. 53. Do I have any other K's? I don't think so. Okay. All right, now what else can I do? What else can I do to figure out anything else? I've used this one. I've used this one. That one's gone. I've used this one. That's gone. I've used this one. This is gone. I've used this one. That's gone. All right. Okay. All right. Is there anything else that equals itself? This thing I kind of need RHC. Do I have RHC? RH. I do. I have RHC, so I can use this one right here. I can find the measure of angle B here. Well, that's cool. Measure of angle B, RHC was 28. So I can find the measure. I might get rid of this over here. I'll just put K. I know that. I'll move this measure of a K over here, up to here. Nice, safe and sound. Get rid of the work for it. And then I'm gonna say by the measure of angle on K. I'll make K like I'll keep my measure red, I guess. All right, so measure of angle WBH, measure of angle W, I like how it did that. Oop. Measure of angle WBH, H equals 9 times this measure of angle RHC. RHC plus 3. Cool. Oops, RHC. Order of operations matters there. Plus 3. Well, I know that this is 28 because I just did that. So I'm going to say that this equals 9 times 28. 9 times 28. Mouse is dragging. 9. So 9 times 28. That's all going to be plus 3. Bring back my calculator. And then we're going to go like this. 9, 28. And that's going to be 3 on top of that. It's going to be 255 equals 255 degrees. And that makes sense because that's a huge angle. Look at that. So this is now 255 degrees. 255 degrees. All right, cool. All right, what else can I figure out? Any line? Well, look at this. Okay, well, I have that this whole thing, right? This whole perimeter equals 236. And they gave me everything over here except this line segment. Well, this line segment, BHB, or HC, is the same as HB. They're congruent. So I'm going to go ahead and just say that, let me get rid of this. I did the work on this one. I'm just going to say that I'm going to turn my line segments to blue. I'm going to say that HB is congruent to HC. Therefore, their measures are congruent. Therefore, a measure of HB. I don't have to put measure. I just do it. I just do this. Therefore, their measures are equal. When I take away the bars on top of them, that just means their measure. And there, then I'm going to say that therefore I'm talking HC equals 4y plus 3. All right, so I have some x's and some y's here though, but I'm still going to put it down there. I'm going to see if I can figure out how to get this x's and this y thing sorted out. I'll pause and think on it for a second. They gave us this one little tidbit of information that I overlooked for a minute, is that this TC is congruent to TK. That's a pretty important piece of information. So we're going to put this on hold just for a minute. I'm going to put this over here just for a minute, and then we're going to move over to this. So in order to solve for x, okay, we're going to say, because that TC is congruent to TX, we can say that TC the measure of TC equals the measure of TX. That's a K. I keep on saying that. It's a K, not an X. There are no X's in this. Right? So now, because the measures are equal, I can say 8x minus 11 equals 3x plus 24. Okay. So again, I like to keep variables positive. So I'm going to subtract 3 from both sides of the 3x from both sides. So it's going to be 5x equals, and then I'm going to add 11x to both sides to get rid of that 11. So it'll be 24 plus 11 is 35. And then x will be 7. Because we're going to divide 5 by both sides. 35 divided by 7 is, sorry, 35 divided by 5 is 7. So x equals 7. So now everywhere where we see a 7 or a 5, we're going to put 7 in there. So I'm going to move this back, move this over here. Take this, get it out of here. And I'll move this back over here. I'm going to put that here. But in the meantime, I'm going to step over here and we're going to substitute x for 7 for x everywhere we see that and change that. Okay, so 8 times 7 is 56, of course, minus 11 is 67. So there's that. This is 67. Wait a minute. No, that was plus 11. 56 minus 11 is 45. This is 45. 45. Now 7 times 6 is 8 times 7 is 56 minus 11. 45, that's right. Okay. And then 7 times 3 is 21 plus 24 is 5. That makes sense because they are congruent. And we have any, and then this one is a y. Okay, so that should be all y's now. Okay. So now that we only have y's left, we should be able to say that, and we know the perimeter. So we should be able, and this is 40. Oh, no, this is, like I said, HC is 4y, y plus 3. Because what we said before, we solved for x, because HB is congruent to HC, then their values, their measurements are the same. All right, and since we know the perimeter of both of these polygons, 236, we just have to add all of these knowns together. So I'm gonna do it like this. I'm just gonna go around and do the variables. I'm gonna do another lap and do the constants. So it might be a little weird to you, but this is the way I like to do it. So I'm gonna do 4y plus 5y plus 7y Okay, now for the constants, plus 3 plus 45 plus 45 Oh, that was big. Minus 11 minus 6. Equals 236. Okay, so I'm gonna add like terms here. I do 4 plus 5 plus 7 equals 16y. Back up the calculator. And I'm gonna do 45 plus 45 minus 11 minus 6. 73 plus 73 equals 236. And I subtract 73 from both sides. Equals 236 minus 73 is 163. Divide that by 16. Gotta come out to a nice pretty number. I'm gonna check the math on this one. Ten point 10.18. 10.19187. I'm gonna pause that and go see if that matches. Probably not. Let's see where I made it. I saw where I made my error. I stopped at -6 and I didn't add the +3, so I left out this. This 3 here when I was adding up my stuff there. So if you're gonna add it the way I did it, make sure you do a full loop there. Don't forget to add one of your constant terms. Right, so this comes out to 16y plus 76, not 73. 73 equals 236. 36. Man, that mouth didn't want to slide. 236. 236. Okay, and then you move the 76. That was 16y equals, where's my calculator go? 16, 236 minus 76 equals 160. That makes a better number. I don't even have to need a calculator for that one. And then y equals 10. Y equals 10. Yeah, so I just forgot to add that 3 there into my initial equation. Right, you put it back up all the time. It'll back up enough. Yeah, you can see there's no +3 in here. So that's where I made my mistake. So just remember to learn from my mistakes so that you don't make them yourself. So anyway, yeah, cool. So y equals 10. Y equals 10. Yeah. All right, so now we know that y equals 10. We can go through and we can add everything to what we can plug in y for 10 there, and then we can solve every length that has a y 10. So let's see, this should be fairly, I probably don't need to calculate this. That's 40 plus 3 is 43. That's 70 minus 6 is 64. Oh man, 50 minus 11 is 39. 39. That's deceiving. That looks longer than those. 39. Doesn't look right. I'm still gonna check. 10 minus 11. Yep, 39. Okay. And that's all the things that have a Y on it. Okay, so cross this off, cross that off, cross this off. And then I can make a congruency here. So this was 43, so this was 43. This was 64, so this is 64. This is 39, so this is 39. This was 45, so this is 45. This is 45. Oops. This is 45. This is 45. It's all of our sides. And then our red, we'll go back to our angles. This is 53, and this is 53. This one's 87, this one's 87. 87. This is 28. 28. Oh, missed a blue one. This is 45. And this was 245 or 255, so this is 255. 255. So we've labeled everything. Everything, all the congruent parts of these triangles, or all these congruent parts of these shapes, polygons, congruent parts of corresponding parts of congruent polygons are congruent too, believe it or not. So hopefully that helped out everybody. That's a lot of work, you know, but it's not too bad. It just takes a while. So hopefully that helped out. I'm looking at the key right now, and it looks like I did all the work right. Yep, that's right. Here, I'll bring it down so you guys can see. So yeah, this is what it determine the lengths, determine, and it just walks you through it in kind of the same fashion. Then later on, it asks you to pull off the angles, you know. So if you just do all the stuff all at once, you just fill in the blanks later. So anyway, I hope everything works out for you with that, and I will post the practice stuff for you guys in a little bit.